All right, everybody, here is the examples that we have. So if you want to go over those, you're welcome to. I gave you a brief example of those. Again, these are both are the same, they're just written differently. So f plus g of x is the same as f of x plus g of x. And we can just look at those examples and substitute what they're equal to, and then simplify our problems. So here's just some examples. We have f of x, g of x, and h of x. Here, for example, A, we want to subtract f and g. Okay, again, this is the same thing as f of x minus g of x. And f of x is 2x plus 4. And g of x is x minus 1. So we substitute what f of x is, we substitute what g of x is, and then we just need to do what we did at the beginning of our lesson, where we add, subtract, or multiply polynomials. So in this situation, we would maybe want to deliver, or distribute that negative. So we have this 2x plus 4, and then we distribute that negative, so we get negative x, and then a negative times a negative 1 would give us a positive 1. Okay, again, if it helps, you can put a 1 there and distribute a negative 1. Right? Then we just need to combine like terms. So we have our x's, so we have x, and then we have our constants, which give us plus 5. So that's subtracting functions. Okay, here we can add. So we're doing, looks like f of x, so f plus h of x, which again is the same as f of x plus h of x. Okay, so f of x is 2x plus 4. And then we're going to add that to h of x, which is x squared plus 3x. Okay, again, here we can drop the parentheses because nothing is being multiplied by the parenthesis. So we could get those gone if we wanted to. And then we'll just combine like terms. So it looks like our highest highest exponent is an x squared, and there's no other x squareds. And then we can combine our x's, so plus 5x, and then we have our constant plus 4. So that's adding using function notation. And then here is a multiplication. So we're doing g times h of x, which again is the same as g of x times h of x. So what is g of x? Well, that is x minus 1. And h of x is x squared plus 3x. All right. And again, if you forgot how to do this, you can go back to our previous video where we did this, but we just need to distribute. So we multiply x times x to the third. Well, that is x to the, x. X times x squared is x to the third. And then x times 3x, well, that would give us plus 3x squared. And then we have negative 1 times x squared will give us a negative 1x squared. And then negative 1 times 3x will give us a negative 3x. So now we just need to combine like terms. Looks like we have our x squareds. So x to the third plus 2x, or squared, minus 3x. All right, so those are the three different types that you'll run into. I guess this one's a little different too. So C, this is f of 2x. So if this is the case, then again, whatever's in this parenthesis is what we're going to substitute into that function. So we can do, well, f of x is 2x plus 4. But what we're going to do is we're going to substitute that 2x into that x. So we'll end up getting 2 times 2x plus 4, which gives us 4x plus 4. Okay, so that one's a little tricky, but again, that is what you do. And it's different than just this is not the same as 2 times f of x, because that would end up giving you 2 times 2x plus 4, which would give you 4x plus 8. So make sure you keep that in mind. Those are not the same. Okay, here's another example. We're doing 2 times h of x, and what's h of x again? X squared plus 3x. So x squared plus 3x, right? Yes, and then we're going to subtract f of x, which f of x is 2x plus 4. All right, and then we're back to problems that we've done before. So we can distribute. Again, we want to do our multiplication first. So 2x squared plus 6x. Again, this is like a -1 we can distribute. So negative 2x and a negative 4. And then we can combine like terms. So it looks like these are like terms. Right. So if you're feeling like you're good with this, then you can probably go on. I will finish this up if you'd like me to. So 5 times g of x, which is x minus 1. So we got 5 times x minus 1, which is 5x minus 5. Okay. Here's another one, h of x, x squared plus 3x. Again, we just substitute what f of x is, put it in a parenthesis, because we'll need to distribute that -4 to everything inside. So -4 x squared, and then -12x, and then we have this plus 1. And again, this plus 1's it's not being multiplied by that -4. So this one is already done for us. We don't need to combine. We can't combine anything. And then this last one, again, this is the same as if you saw it as f times g of x. But here, I think it makes more sense sometimes maybe to think of it that way. So f of x is 2x plus 4. And we're going to multiply it by g of x, which is x minus 1. Okay, and I also mentioned about, like, we could do this using like a box. So I'm just going to do this one this way. So 2x plus 4 and x minus 1. So all we need to do is do a multiplication table. So 2x squared, because x times x is x squared. X times 4 is 4x. 2x times -1 will give us a -2x. And then -1 times 4 is a -4. So then we just need to write it down. So 2x squared, that's our only x squared. And then we have our 2 x's. That give us 2x. And then minus 4. All right. Well, if you have any other questions, this is the majority of what will be on the test is doing function notation. So make sure you're feeling comfortable with this. I'm here before after school if you have any questions. All right, we'll see you guys.